Robots. They are everywhere. They've been our silent companions for decades. In factories, on our streets, and in our homes. They deliver our parcels, clean our bathrooms, make our coffee, and cook our meals. They're even in our operation rooms. But here's the thing. Most robots are still instruction-based machines, brilliantly engineered for specific tasks, but completely lost when faced with the unexpected. A small change in the environment condition around them can fail them, or damage them, or even harm us. Meanwhile, artificial intelligence has been absolutely crushing it. AI talks to us like a friend and reads our emotions. ChatGPT, Claude, Grok, Gemini. They're having meaningful conversations with millions every day. AI tools can analyze image and voice and create perfect videos just like the real world based on prompts. But here's the catch. All this incredible AI brilliance, it's trapped in the digital world, inside computers and phones. They don't have physical capabilities, like how robots do. The reason is that current AI systems like ChatGPT are trained on text, audio, and images. So it's great at predicting the next word and pixel, but it was never trained on physical actions, how objects actually move or behave in the real world. So they can't generate action signals. There is a fundamental difference between these two. Think about learning to ride a bicycle. You can read every book about cycling, understand the physics of balance and momentum, even watch thousands of videos. But until you actually get on that bike and experience the wobbling, the falling, the precise muscle adjustments needed to stay upright, you can't ride. Your body needs to learn balance reflexes and hand-eye coordination through physical practice, not just intellectual understanding from books or videos. It's exactly the same with robots. Current AI systems can't add real intelligence to robots because they don't understand physical actions. You can't just plug ChatGPT into a robot and expect it to walk, grab objects, or navigate the real world. They need to be trained on action signals, learning from force measurements, motion trajectories, collision responses, and cause and effect relationships in the real world. Instead of predicting the next word, they need to predict the next physical action, like how much force to apply and which direction to move. What we need is a completely different type of AI that can send precise action signals to robot motors and actuators, learning through physical experience just like we learned to ride that bike. This fundamental gap between digital intelligence and physical capabilities is what the entire robotics industry has been trying to solve. It's like AI can tell you about physics, but it can't control a robot to catch a falling glass before it shatters. Sometimes, words are not enough. So, here's the trillion-dollar question. Can AI systems truly understand our physical world? Can robots move beyond just following instructions to actually interpreting what's happening around them? Can they handle the unexpected and reason their way through it like we do? The answer is about to change everything we know about intelligent machines. Physical AI.
Okay, let's talk about physical AI.
It doesn't just exist in computers, but moves through our real world, predicts how objects behave, and takes physical actions in real time. Not based on instructions, based on understanding from physical world. Many say it's the biggest AI leap since ChatGPT. And yes, tech giants believe it's the next trillion-dollar industry.
This is bananas numbers, you know. I should say $200 trillion.
Through the developers and ecosystem partners, There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP.
Tesla would basically make about $1 trillion of profit a year from that.
But what is physical AI? Let's start with tracing the incredible journey of artificial intelligence so far. AI has evolved through 4 major steps. First, we had perception AI, giving machines senses. Think of facial recognition on your phone, voice assistance, or object detection. Machine learning that tells us what it sees. Then came generative AI, the era of ChatGPT, Claude, and others. These models create content, text, images, audio, videos, and even computer codes. Next, we saw agentic AI that makes decisions on its own. It plans, acts, and solves problems proactively. It's like having an AI that doesn't just answer business questions, it actually runs parts of your business 24/7. And now we've entered the era of physical AI. This is intelligence embedded in real-world systems, robots, vehicles, and machines that think and act in real time. Physical AI extends proactive digital intelligence into the material world. Where traditional AI relies on clean, cloud-based data, physical AI operates in the messy, unpredictable real world, and it needs to respond fast. It uses sensors to perceive its environment and actuators to interact with it. There's no time for cloud lag. It runs on edge computing. It has to predict motion, adapt to physics, and recognize objects, even when they're out of sight. Training physical AI is no easy feat. It's a difficult and long process. It requires cameras and sensors to collect real-world physical data, plus robotic equipment for practicing motion controls and skills. Most importantly, it needs skilled engineers and human trainers to demonstrate tasks across countless scenarios and environments. This could be simple actions like making a toast, complex tasks like surgery, or precision work in factory settings. Training physical AI is expensive because of 2 limitations: training data from the real world and train process in the real world. Training robots requires massive amount of physical world data, thousands of hours of videos collected and labeled, years for data collection and training, millions of dollars in equipment, and armies of engineers and skilled workers working around the clock. That's why only a few companies are leading the charge. Waymo handles 150,000 driverless trips each week. Boston Dynamics Atlas performs near-human acrobatics. Tesla's FSD is driving cars, and Optimus is folding laundry in factories. Real-world training is slow, risky, and costly. Just imagine training a surgical robot. Mistakes aren't an option. But here is the game changer. What if we don't need real robots and real environments to train robots? What if we could create a perfect digital copy of the real world? What if robots could experience millions of lifetimes of training in virtual environments that perfectly obey the laws of physics? Welcome to digital twins. Not just 3D models, but physics-based simulations. Making digital twins have transformed how we can overcome both the limitations we have in training physical AI. Remember those limitations we talked about? The expensive real-world data collection and lengthy training processes? Digital twins solve both problems by creating virtual environments that behave exactly like reality. Instead of collecting data from the real world, we generate it virtually. Instead of training with physical robots, we simulate them digitally. This approach lets us create massive amounts of training data and train countless robots in countless scenario simulation, saving millions in equipment costs and years of development time. They simulate everything: momentum, fluid dynamics, structural mechanics, electromagnetics, and cause and effect. These systems create AI that reasons about causality rather than correlation. This creates a perfect simulation environment to train robots instead of training them in real world. Platforms like NVIDIA, Omniverse, and Cosmos, which is trained on 20 million hours of physical world video to amplify the data and videos we collect from the real world. You give it a few videos, and it can simulate multiple scenarios of materials, forces, and motion in multiverse. NVIDIA dominates physics simulation, but it's not just one platform. Microsoft merges the virtual and real with HoloLens and Azure Digital Twins, leading in digital physical interface. And Boston Dynamics focuses on real-world embodiment, pushing movement and mobility. And there are many other platforms. Each brings a piece of the puzzle. Together, they're building the foundation of physical AI.
What is love? Baby, don't hurt me. Don't hurt me no more.
To recap, there are two primary ways to train physical AI. One, real-world data, based on what happened. They are accurate but expensive, risky, and limited in scale. And two, digital twins, based on why things happen. They are fast, low-risk, highly scalable across unlimited scenarios, but still faces sim-to-real transfer challenges. The most effective systems? They combine both and use a hybrid approach. Simulate first, then fine-tune in reality. So what's next? The future of physical AI is mind-blowing. Imagine AI robotic teams coordinating in disaster zones. AI factories producing customized intelligence for every industry need. And most exciting of all, human-AI symbiosis, where machines augment our actions, not replace us. Where physical AI predicts human intent, provides assistive capabilities, and amplifies our natural abilities while keeping humans firmly in control of critical decisions. Add quantum computing. Future QPUs will astonishingly increase the computation speed. We'll simulate molecular dynamics, design new materials, and understand physics at levels that are computationally impossible today. With physics-informed neural networks, advanced sensing technologies, agentic reasoning, in digital twins, we're approaching a world where the boundary between digital and physical intelligence disappears and machines think and act in reality, just like us. This is physical AI. The question isn't whether physical AI will transform our world, it's whether you'll be ready for it. Subscribe to stay ahead of this technological revolution of our lifetime, and let us know in the comments, what physical AI application excites you most?